is our content, reason, and purpose. In our 21st century, the space available for use has become less and less, and finding parking space in the city has become very difficult. Sometimes it takes a lot of time to find a parking space and find your wrong car later, so our team decided to design an intelligent system parking lot to make parking faster and easier. The cost of parking in cities in the near future will be higher and higher as the density of the population will continue to increase. So we need a space-saving underground parking lot so that the cost of parking will not too expensive.
The leader diagram construction has 9 steps. 1. Define the process to be controlled. 2. Make a sketch for the process operation. 3. Create a writing step sequential list of the process. 4. Add sensor on the sketch as need to carry out on the control sequence. 5. Add manual control as needs for process system or operation checks. 6. Consider the safety of the operations personnel and make addition and adjustments as need. 7. Add master stop shift as required for safe shutdown. 8. Create the ladder logic diagram that will be used as a basic from the PLC program. 9. Consider the what if when the process sequence may go wrong. The 1. Define the process to be controlled. We have 2 elevators. The enter elevator, when the vehicle touches the shift from the first floor, the elevator returns to the first floor. Then the vehicle drives into the elevator. Wait for 5 seconds, the elevator downstairs to the basement. After vehicle leaves the elevator returns to the first floor. About the basement, after the vehicle is parking in the parking space, the sensor will light up the lamp. Let them other driver knows there is any other parking.
This is our input and output. And S0 is power switch. S1 and X5 is one floor entrance limit switch. S2 and S6 is elevator upper limit switch. S3 and X7 is elevator lower limit switch. S4 is P1 entrance limit switch and exit limit switch. X10 is emergency switch. And our output, Y0 is source lamp, Y1 is operation lamp, Y3 is elevator return, Y4 is elevator downstairs and upstairs, Y5 is bus, Y10 is fog lamp. And this is our process. When the S0 is on, the system starts. The vehicle passes first floor. Elevator will return to first floor, and the vehicle driving to elevator. Wait for 5 seconds. The elevator will downstairs. PLC will judge if the elevator touch the lower limit switch. If yes, the motor will stop and the vehicle can leave the elevator. If not, the fog lamp will on and the bus will go off. And the process of the elevator is the same.
Step 4 and Step 5. Add sensors on the sketch as needed to carry out the control sequence and add manual sensors. According to design action, we add the required sensor and switches. On the control box, we use 3 lights, 1 switch, 1 buzzer, and 1 EMS. The green one is source lamp, the red one is operation lamp, the orange one is fault lamp. In addition to control box, we also use several micro switches to complete our actions. The next page is talk about security, step 6 and step 7. Consider the safety of the operating personnel and add master stop switches. If the vehicle enters the elevator after 50 seconds, it cannot reach the basement. Motor shut down.
This part will be my presentation. I'm going to talk about our SFC step. Let's talk about entrance elevator first. When the car throws the X1, if the elevator isn't at the first floor, it will return it. Then car throw the X1 again and drive into it. Elevator downstairs basement. After arrive, the car drives out of the elevator. When the car throws the X4 for twice, the elevator returns to the first floor. Exit elevator has the same process. If it has fault, the program will jump into block 14. Then fault lamp on and buzzer go off.
Let's take an inside look at the hardware equipment of our project. As you can see in the picture, we set up 2 elevators to lift and lower the car. This side is the entrance, and the other side is the exit. After driving into the basement, we can park the car in the parking space. Although we only use lights to show whether someone is using the space, we hope the automatic space management could be used in the future, such as some intelligent features like car owner identification, or automatic bill payment. Next, let's watch a working video of our project.